Hello, in this short video we'll be looking at the application of Newton's second law and looking at masses on a pulley system. So let me draw it. Here is as in only in physics and mathematics do we have such things, a completely frictionless pulley. So it's a pulley and it has no friction, making life a lot easier. And what we're going to have two masses hanging on it, and we're going to look at the mathematics of the acceleration. So let's say attached to the same piece of string. So I'll try another colour on here. We have a nice blue. We have two masses. This is the smaller mass, which we will label little m, and here we'll have a larger mass, which we will label capital M. Now the question could be something like okay, so algebraically calculate the acceleration. So putting the whole terms into the form of what a is. So basically, express in terms of acceleration a. So again, assuming m is greater than m being a greater mass than little m. So the first thing we need to do is we need to draw the forces acting upon this system. So I'll change it slightly. So now we're going to add on the forces. So this is the mass little m. So the force, pretty simple, mass times g. mg gives us the weight acting there. And we'll also have a force here, also its weight, but this time it's big M times g. Now we need to use a little bit of common sense here. Now, in which way will it accelerate? Well, it's going to accelerate in the direction of the greater mass. So I'll represent acceleration with a double arrow, so it's going to accelerate this way and that side. So if this is a string connecting them, if that accelerates down in that direction, this will accelerate up with the same acceleration but in the opposite direction. Same size of acceleration but in the opposite direction. Now the other forces acting on these masses is the tension in the string, and because the pulley has no friction, we're going to represent it the same tension. So if this has got a tension T acting up there, then with a string the tension is always the same throughout the string. Always the problem when two objects are connected by a string is the tension will be acting up there in that direction, but also acting there. So that feels a tension on the string, that feels a tension in the string, and the whole motion is acting down, accelerating in that direction. Now in the next slide we'll look at the equations. Okay, so what I'll do is I'll rub this out and give ourselves a little more space to add some of the equations. I will rub that out there, and I think we've got space here on the right hand side to do that. So we're looking at this system first of all. When you're doing this type of question, be it the lift style questions or trucks towing caravans and things, we always separate the systems. So first of all, let's have a look at this system here. So this we have on this system here. So I'll put dots around there. We'll isolate this and apply Newton's second law, which is force equals mass times acceleration, or better still, resultant force equals mass times accelerating. Now we know the acceleration is acting up that way, so this force, the resultant force, must also be acting in that direction. So resultant force, make it positive, is the tension minus the weight, that's the resultant force, is simply equal to ma. And this of course is applying F equals mass times acceleration, where that's the resultant force. So that's equation 1 to that system there. And equation 2 relating to this system here, so we're just, all we are is now just looking at that system in isolation from every other system. We're looking at this. This time we're going to have the weight is going to be in that direction, so the weight must be greater than the tension. So we have mg minus the tension is equal to ma. That's equation 1 and equation 2. So in a moment we will exploit these two equations. So now what I'm going to do, I'm going to rub off the main picture, which of course you can look at again, and we're just going to look at these two equations. The physics is over now to a certain extent, now it's on to the maths. So I shall rub this out. Now the original question was express in terms of A. So how are we going to deal with equations 1 and 2? So simultaneous equations, and a good way to deal with them of course is to add equation 1 to equation 2, which eliminates the t. So let's do 1 plus 2. And that will give us, adding those together, it's a positive t and negative t, they'll cancel out to give us mg minus little mg is equal to ma plus ma. We've added the two equations. Now we'll need to do some factorization because we want to give it in terms of a. So that can be simply g bracket m minus m equals, and let's factorize this, a bracket m plus m. Now we're almost there, so now we just need to divide through by m plus m, and as generally the case we leave the a on the left hand side, so we'll do that in one step. So therefore the acceleration is simply equal to g times the big mass minus the little mass divided by the little mass plus the big mass. And sometimes the question asks you just to leave in that form, otherwise you can add the values for it in some questions, and then necessarily find the tension from there. Okay.